is traveling like this. When it reaches this point, with the vertical diameter, the radius makes an angle, theta. Right? At this point P, the body is reached. At this position, weight of the body is acting vertically downwards. So this weight mg can resolve into two components. One is mg cos theta and other is mg sin theta. Am I correct? Okay. Though the body is moving on this direction, the acceleration will be always toward the mean position. Remember that. Okay. That is why mg sin theta tries to take the body toward the lowest point. But the body is moving in the circular path only. You don't confused with that. Mg is resolved into two components. One is mg cos theta and another is mg sin theta. Along the radius, the forces acting are T minus mg cos theta. T is toward the center and mg cos theta is away from the center along the radius. Along the radius, away from the center, the force acting is mg cos theta. Therefore, the resultant force acting on the body that will provide for the centripetal force is T minus mg cos theta. That is what it says. T minus mg cos theta is equal to mg square by r. At L, so this relation is a general expression for every point. T minus mg cos theta means any point this point can be taken as P, this point can be taken as P, this point can be taken as P. At any point, so accordingly as the value of theta, we can calculate the tension at those points, right? At the point L, when the point is L, theta is equal to 0. T is equal to TL and V is equal to PL. Therefore, we can write TL is in place of T here, you will put TL minus mg. Mg is also as it is, but theta is equal to 0. Suppose the body is at the point L, then this radius is coming back to this point. Therefore, theta is equal to 0. But cos 0 is equal to 1. Am I correct? Therefore, TL minus mg cos 0. TL minus mg cos 0 is equal to mg only. Cos 0 is equal to 1. That is equal to mvl square by r. Therefore, TL minus mg is equal to mvl square by r. Already we have proved in the earlier case, in the previous case. Then suppose the point is at H. When the body reaches the point H, what is angle? Angle is equal to 180 degree. Now, in place of cos theta, you will put a cos 180. But cos 180 is equal to minus 1. Therefore, at H, T is equal to TH, P is equal to PH, and theta is equal to 180 marked here. I think you are able to see that. 180 is marked here. Therefore, TH plus TH minus mg into cos 180. Cos 180 is equal to minus 1. Minus into minus is equal to plus. That is why TH plus mg is equal to PH square divided by r. That also done. Right? Okay. Now we are saying is what is called TC. What is the tension at the point C? At the point C, T is equal to TC and V is equal to VC. Right? Is equal to VC and theta is equal to 90 degree. Theta is equal to 90 degree means cos 90 is equal to 0. At the C, T is equal to TC, V is equal to VC, theta is equal to 90 degree. Then TC minus mg cos 90, that is equal to mg into cos 90 is equal to 0. You are getting as equal to 0, right? So then we say TC minus mg cos 90 is equal to m into VC square divided by r. Therefore, TC is equal to m into VC square divided by r because mg cos 90 is equal to 0. Am I correct? So this is the condition. But everybody knows that TC is equal to, but everybody knows that VC is equal to root of 3mg. Root of 3mg. You can put the value of root of 3mg. VC is equal to root of 3mg. VC square is equal to simply 3mg. We can calculate the value of TC also at the horizontal point. So these are the conditions. So the complete notes you will see. Zoom this the written notes on the board, and you can write it. First part is this much, right? Second part is this much, and third part is this much, and this is the fourth and the last one. These are points to remember. That is, to maintain a circular motion in a vertical circle, velocity at the top VH must be greater than or equal to RG, and at the bottom VL must be greater than or equal to root of 5 RG. VC must be equal to or greater than equal to 3 rg, should not be less. Greater than means there no, but if the velocities are less, then the body will not be able to move in the circular path. TL is equal to 6 mg, TH is equal to 0, TL minus TC is equal to 6 times the weight of the body. All these things you will remember. Then I have faith. I absolutely believe that you will be able to do all the numerical problems related to this topic. All these formulae you must remember. What is critical velocity? Critical velocity is the velocity of the body at the highest point when the velocity is when the tension at that point is equal to 0. That is critical velocity. Sometimes in some books, VH is given as equal to VC is equal to root of RG. At that time, the velocity at the bottom will be equal to root of 5 RG. If one can maintain this velocity, then the body will move in a circular path. If you take a bucket full of water, when it is rotated like this, even at the top of the motion of the vertical circle, the water is not coming down. Because in that case, the centripetal force is greater than the weight of the body. Suppose a pilot is sitting in a warplane and he's taking loop in a vertical circle. Even at the top of the vertical circle also, the pilot is not falling down because the weight of the person at that point will be less than the centripetal force acting at that particular point. So these are the points I had to tell you, and see the video very carefully and with the full attention, and note the points down, all the formula you had by heart. Then you will be able to do all the related problems in this topic. And I will come with numerical problems and some more things in this topic in the next class. Till then, bye bye.